I don't understand Twitter or why it's so popular.
I don't use Twitter.
Because you can complain to people.
But here's the thing. That's why can't you do that? That's Facebook's for that too. You understand what I'm saying? Like,
That's for old people.
Okay, it's for old people. More like Twitter is for dumb people that can only have ideas big enough for 160 characters or 140 characters. Mobile tweets. What's the point then? It's like Facebook. You can write as long of a status as you want.
Twitter is like if you're upset with someone and you don't tell them, you go on Twitter and while you're upset.
Well, that's people do that on Facebook too. It's like that's what
only old people will see it.
That's why you had it.
Well, I understand, but it's so silly. It's so silly. Anyway, all right, back on topic here. Well, true, but yeah, true. Okay. So particle motion is what we're talking about today. So in discussing motion, there are three closely related concepts that you need to keep straight. They are, okay, the first one we'll talk about is the function x of t, okay, and that deals with the position normally. Okay, x of t, sometimes you'll see like s of t for position as well. Just depends, okay. Okay, and the units for that, as an example, right, you can talk about like meters, right, okay, so like m, right, or feet, because yes, sometimes you'll see feet here, and I know that's going to bother some of you physics folks, okay, right. Position is just a measurement, kind of like almost like of a distance in a way, okay, so that's position, okay, so position is your like one main idea, and then next to that is velocity. We also need to have an understanding of velocity. Okay, that normally is represented as v of t. Okay, and the way that we relate position and velocity, okay, in calculus, is that the derivative of the position, x prime of t, is equal to the velocity, which kind of makes sense, right? What is the derivative? It's the rate of change. So the derivative of the position would be the rate of change of the position. That's the velocity. Mind blown, right? Okay, so if it's velocity, so that means we're talking about like meters per second, right? Or like feet per minute, or something like that, right? You'll have now a measurement per second. So again, there's that rate idea showing up in the units, meters per second, feet per minute, right? Per. It's a rate now. Take the derivative. And then we should also be then familiar with the acceleration. Okay, that's our third kind of concept that's related there. Okay, and that's normally denoted a of t. And anyone want to guess how you get the acceleration from the velocity? The derivative of velocity is acceleration, which means then that the acceleration is also related to position. How is it related to position? Second derivative of the position. So x prime of t. Okay? And again, it makes sense, right? Acceleration is the rate of change of the velocity. It's how the velocity is changing, right? Either you're speeding up or you're slowing down, right, for the velocity. That's described by acceleration. Okay, and so in this case, what are the units for acceleration? For example, if we had meters per second in velocity, what would it be for acceleration? Yes, meters per second squared. And just the seconds are being squared there, right, not the meters. Meters per second squared. Or it could be like feet per minute squared. Okay, so there's the relationship. Okay, also in these problems, we're going to be seeing some English, right? Because that's what we speak, and that's what we read in this class. But then we need to be able to translate that English into math and like what the meaning is, right? So, for example, if we start with the idea that x of t represents the position of a particle along the x-axis at any time t. Okay, so t represents time, right? X of t is the position at time t. Then this means initially means when what equals 0? T, right? At time t equals 0, that is what initially means. Because if you're starting out, time is 0. Okay? If we're talking that it's at the origin, that means what is equal to 0? X of t, the position, is 0. Okay, because again, x of t in this case is representing the position of the particle along the x-axis. So if the particle is starting at the origin, that means the position is starting at position 0, because what's the x-coordinate at the origin? 0. So that means then that x of t is going to be 0. Okay. At rest means what equals 0?
V of t.
V, the velocity. The velocity equals 0. Okay, at rest means the particle is not moving at all. It's at rest. So the velocity is 0. It's got no rate of change of its position. Okay? If the velocity of the particle is positive, then the particle is moving, in this case, in what direction?
To the right.
If we're moving along the x-axis, what is a positive motion on the x-axis? To the right. Yes, that's exactly right. Okay. If our particle is moving along the y-axis, and we had a positive velocity, then what would that indicate? We would be moving up, right? Up is a positive direction there. Okay. So velocity has two parts to it. You can think of. Velocity has not only kind of like, a value, right, like a number value, but it's also got a sign to it, positive or negative. So positive is going to be one direction, negative will be in the opposite direction. Okay. So if the velocity of the particle is blank, then the particle is moving to the left. So this blank would be what? Yeah, if we have a negative velocity, that indicates the particle is moving to the left. Again, because this particular position function is describing a particle moving along the x-axis. So a negative velocity would be going to the left. If our position function was describing a particle moving along the y-axis, a negative velocity would mean the particle is moving down. Okay? Okay. To find the average velocity, okay, key word here is average. Average velocity over a time interval, divide the change in the what? Position by the change in time. Okay. So average velocity, that's like that secant slope we've talked about before, right? The secant slope. You're literally doing the slope formula. Position, change in position divided by change in time. Okay? Instantaneous velocity is the velocity at a single moment. That is an instant in time. Instantaneous velocity means we're going to be looking at what derivative? The derivative of, not the derivative of v, it's the derivative of, of the position. The position's derivative. So to find the instantaneous velocity, that is the derivative of the position, which is the same thing then, yes, as v of t. Brandon there, yeah. Same thing. So it's x prime of t or v of t there for the instantaneous velocity. Okay? Again, instantaneous, right? That's the derivative. The derivative is the slope at an instant. So if we want to find the instantaneous velocity, it's the derivative of the position will give us then that instantaneous velocity. Okay. If the acceleration of the particle is positive, then what's happening to something's increasing then? The velocity will be increasing. If the acceleration of the particle is blank, then the velocity is decreasing. Negative. Right? In order for a particle to change direction, the blank must change signs. So I hear position, I hear velocity. So let's think about this. What thing determines the direction of the motion of the particle? The velocity does, right? Specifically, if the velocity is positive, it means the particle is moving to the right or up, or depending on what the way the particle is moving. If the velocity of the particle is negative, it's moving left or down, again depending. So, in order for a particle to change direction, the what must change signs? The velocity is what must change signs. Yeah. For velocity? Yeah, it's the derivative of the position, in other words, if you want to say that. Yep. Okay, questions on any of that? Okay, let's flip it over and see this at work then. Okay, so, example 7 here says, the data in the table below give selected values for the velocity in meters per minute of a particle moving along the x-axis. The velocity v, is a differentiable function of time t. Okay, so it means the velocity we are able to take the derivative, right? That's what differentiable means. The derivative exists for the velocity. Okay. So here's our table. We can see that at time 0 the velocity was -3, and then at 2 it was 2, 5 was 3, 6 it was 5, 8 the velocity was 7, and the time t equals 12 minutes, velocity was 5 meters per minute. Okay. So letter A. We have no idea, by the way, what happens between these points. Okay. However, here's one thing I'll ask. Between these points, right, so again we have a bunch of coordinates here. We have the coordinate 0, -3, 2, 2, 5, 3, 6, 5, 8, 7, 12, 5. Will the velocity be discontinuous between any of these two sets of points? How do we know? Because the velocity is differentiable, therefore, what do we know? Differentiability implies continuity. So if the velocity is differentiable for any of these t values, that means it will also be continuous between any of these values. So we don't have to worry about some like weird behavior happening between these 2 points, these 2 points, these 2 points, or anything like that. It will not have a jump, a gap, or a hole, or anything like that. Since velocity is differentiable, it is also continuous. I'm going to write that here. V of t is continuous. Therefore. Okay? So V of t is continuous, therefore. All right, let's get into an actual question here then. All right? So letter A says, well, actually, any question here about just the setup? Any question here just about the setup? We're all okay with that? All right, so letter A. At time t equals 0, is the particle moving to the right or to the left? To the left.
To the left.
Explain your answer.
The velocity has a negative value, and therefore, instead of going along the x-axis, it's going to go to the left.
Okay, so the particle is moving to the left. Is that good enough? No, explain. If it says explain, guys, you got to explain. The particle is moving to the left because the velocity is negative at t equals 0 minutes. Okay, and you can abbreviate the, minutes to MIN if you want to. Okay, no it's. So don't say so what you should not say here is the particle is moving to the left because it is negative at time t equals 0 minutes. What's it? You never established that we were talking about the velocity here. So using that pronoun it, it's going to be confusing to someone that's grading you, okay? So in general, avoid using pronouns. Never use it. Always refer to the thing that you're talking about. Okay? No it. Okay? No it. Because the velocity is negative. Okay? Letter B. Is there a time during 0 less than or equal to t less than or equal to 12 minutes? Where did they get this interval from?
That's your range of t.
That's the range of our time in our table here, right? So this is not some arbitrary range. This is the exact range of time that we are shown in our table here. Okay, so is there a time during 0 less than or equal to t less than or equal to 12 minutes when the particle is at rest? Explain your answer. Ryan?
Yes, because at some point when t is greater than or equal to 0 or less than or equal to 2, the velocity has to cross. If you're thinking of it as a graph, it has to cross 0 because it's differentiable and continuous at all times.
That's right. What theorem might we be able to apply here?
Intermediate value.
Intermediate value theorem. I told you it was coming back, and here it is. Okay, so since v of 0 equals -3, right, and v of 2 equals 2. Okay. And I'm going to put parentheses, and v is continuous since v is differentiable. Okay, so this is all setting up the intermediate value theorem. We have our interval here from 0 to 2. Our y values are changed from -3 to 2. Okay, so since that's true, and we have to also establish that v is continuous since v is differentiable. Okay, we have to establish that that's part of the intermediate value theorem. So since that's all true, then there must be a time t between 0 and 2 such that v of t equals 0 by the intermediate value theorem. Okay. And that's it. So there it is. Okay. Do you have to use the words intermediate value theorem there? No. You probably could have stopped right there by establishing the the endpoints there go from -3 to +2. Then there must be a time t between 0 and 2 such that v of t equals 0. You could probably just put your period right there, and you don't have to say by the intermediate value theorem. Okay. You don't have to mention it by name. You have to name drop. Okay. Now, one thing I did want to point out here, and I apologize for not attacking this earlier, Ryan correctly interpreted it, so that was good. But when we say, again, when the particle is at rest, right, that's why we went through that whole thing on the front here. At rest means velocity equals 0. So if you want to, when you see that word, that phrase, like at rest, you can put right there for yourself. That means v of t equals 0, if that helps you. Okay? Just like interpret some what they're being asked for. Okay? All right. Any questions on that? That, I would say, is a complete answer. Like I said, you could stop here after the v of t equals 0. You don't have to put by the intermediate value theorem. But that was, I would say, is a complete good answer. You want to establish the conditions for the intermediate value theorem. Our y value changes from -3 to +2, and v is continuous since v is differentiable. Okay, so then there must be a time t between 0 and 2 such that v of t equals 0. How many times must we equal 0 between -3 and 2? It could be, we have no idea how many, okay, but we can guarantee at least once, okay? So it could be 5 times, okay? My graph could go from that 0 to -3, it could something crazy between there, like wave, back, oscillate between, and then go to 2, 2. All right, it could, but we don't know, okay? Same thing here. Could there be a 0 between these 2 points? There could be, but we're not guaranteed one by the intermediate value theorem, right? We know that we have to go from the y value of 2 to the y value of 3 there. It could go down and back up. We don't know. So we can't guarantee one. But because we go from -3 to 2, we were guaranteed we at least have to cross through the 0 there once. Okay? So just keep that in mind. Okay? What is the average acceleration of the particle over the interval from 2 less than or equal to t less than or equal to 5? Show the computations that lead to your answer and indicate units of measure. Okay, so if I want to find average acceleration, okay, I'm going to do like a little m here for the slope. Okay. Average acceleration. Yeah, we need 2 points. Okay, what is the acceleration? How do we find the acceleration? It's the derivative of the velocity. So instead of maybe saying average acceleration here, let me put a line through this, and we'll instead say average, the derivative of the derivative of velocity. We could say the average rate of change of the velocity of the particle. Okay, why have us do this? Because average acceleration, students are going to want, in their slope formula, you will want to do this. A of 5 minus A of 2 over 5 minus 2 for your slope. Okay? This is not right, though. This formula, okay, is like the average rate of change of the acceleration. We want the average rate of change of the velocity. We want the average acceleration. So this formula is not average acceleration. It is not average acceleration. Okay? The average acceleration is found by doing the average rate of change of the velocity. Okay? Average rate of change, that's the slope formula, but we're not going to use acceleration here. We're going to use what? The velocity. So it's v of 5 minus v of 2 over 5 minus 2. Okay? This is average acceleration. Okay?
Couldn't you denote that as delta V over delta T?
Yeah, delta V over delta T, yep.
Which would just be...
Okay? So, and that's a little bit confusing. Again, we'll see that more and more, but we have to be very careful about that. When it says average acceleration, think about acceleration as being the rate of change of the velocity, and that'll help. Average rate of change of the velocity, that's the slope. Remember, anytime you ask for an average rate of change, it's the slope formula. y2 minus y1 over x2 minus x1. Okay? Average rate of change is the slope formula. It's that secant slope. Okay? Tangent slope, you're going to take the derivative. All right, great. What's v of 5? 3. What's v of 2? 2. Over 5 minus 2, which is 3. So 3 minus 2 is 1/3.
That's
Ooh.
not right. You need a unit.
Show the computations. Right, we're not done yet. Show the computations that lead to your answer and indicate units of measure. What are the units of measure going to be here?
Meters per minute.
Meters per minute squared. Okay, that's correct. Now, if you're concerned that you're like, I'm not sure if I'm going to be able to come up with that on my own, just look back to the calculations we just did. What are the units for velocity? What are we told they are? Meters per minute right there, right? So these top numbers are in meters per minute. And then these bottom numbers are units of what? Time, so their label will be what? Minutes. So we're taking a number here. This number 1 is in meters per minute, and we're dividing by minutes. So meters per minute, let me do it this way. Meters per minute divided by a number that's in terms of minutes is the same thing as doing meters per minute times 1 over minute. Right? Dividing by something is the same thing as multiplying by the reciprocal, 1 over minute. Dividing by minutes is the same thing as multiplying by 1 over minutes. And look at that. Meters times 1 is meters. Minute times minute, minute squared. Okay? So there's your units. Should acceleration be in a unit of length divided by time squared? That's exactly the units for acceleration, right? It's a measurement of distance divided by time squared. Okay? Had we have done this, had we done it this way, what would our units have ended up being? Acceleration would have been in what units? Meters per minute squared, but then dividing by minutes again, meters per minute cubed. That does not make sense for an average acceleration, meters per minute cubed, right? And so that's another thing that can help you kind of like remember this if you're ever like unsure. It's like, should I do acceleration when I'm trying to find average acceleration in my numerator, or should I do velocity when I'm trying to do average acceleration? Think about what will lead to the correct units. If we use velocity, we'll have meters per minute in the numerator, divided by minutes, we'll end up with meters per minute squared for our average acceleration. That will give us the correct answer, so that's why we use velocity. That's another kind of like indication to use that velocity. Okay? So, sorry, I spent a lot of time on that one because it is not as easy for students to pick up on for whatever reason. Okay? I kind of get it. It's asking for average acceleration, so your temptation is to do, A minus A over your time. But no, change in velocity. Okay. Any questions on that? Part C? All right, let's look at letter D then. Use data from the table to find an approximation for v prime of 10 and explain the meaning of v prime of 10 in terms of the motion of the particle. Show the computation that leads to your answer and indicate units of measure. Okay, so v prime of 10, what is that we're being asked to find then? The acceleration at 10. And the acceleration, right, or we can also think about this as being called the rate of change of the velocity at 10. How are we going to do that with this table? We don't even have 10 shown up on our table there. Yeah, right.
The average acceleration between 8 and 12.
Yes, so 10 fits squarely between 8 and 12, right? This velocity, v prime of 10, that's a time equal to 10, right? 10 fits right in the middle of 8 and 12 there. And so if 10's right in the middle, and I want to approximate the derivative, I'm going to find the slope between these 2 points. The point 0.87 and the point 12.5. Find the slope between them, and then that we can use it to approximate, right? An approximation of v prime of 10 will be like the average rate of change here. So it's a slope formula. Okay? So v prime of 10 is approximately v of 12 minus v of 8, the average rate of change between those 2 points, over 12 minus 8. Okay. V of 12 is 5. V of 8 is 7, according to our table. 12 minus 8 is 4. And so you get negative 2 over 4, or negative 1 over 2. What do I need to have written right next to it, though? Units. So what would this be? What would the units be? Meters per minute squared. Good, because this is really like an acceleration, right? If I'm taking the derivative of velocity, that's an acceleration, so this should be acceleration units. Okay, again, if you're like, Mr. Witt, how am I supposed to remember that? Well, just, again, go back to velocity. We did velocity units, meters per minute divided by minutes. So meters per minute divided by minutes, meters per minute divided by minutes, meters per minute squared then. Okay. Now, I'm going to write a little sentence here, because it doesn't say to write a sentence, but I'm going to write a sentence just to kind of describe, to interpret what this means. So, the particle's acceleration is negative 1/2 meters per minute squared. Okay? So it's like, duh, we already showed that, Mr. Wade. Why are we writing this sentence? Okay, well, the particle's acceleration is negative 1/2 meters per minute squared. Is it always going to be negative 1/2 meters per minute squared?
No, it's
at what?
T equals 10.
At t equals 10 minutes. So, I heard Ryan mention the word decelerating here, okay, which is possibly true. But it could actually be accelerating here with this negative acceleration. You might be wondering, wait a minute, why is that the case? Well, let's go back up to our table here. So if we're assuming, right, what do we assume, what will the velocity be, positive or negative at time t equals 10? We'll assume it's positive because at 8 it's positive and at 12 it's positive. If we assume that, which we're assuming, we don't know for sure, but if we assume, if it follows this kind of behavior here, then at time t equals 10 we'll have a positive velocity. If we have a positive velocity and a negative acceleration, that means we are accelerating or decelerating. But overall, we're slowing down, right? We are decelerating. If you have a positive velocity and a negative acceleration, those are counteracting each other, and so the acceleration is dragging down the velocity. It's decreasing it.
Negative velocity and negative acceleration.
Right. If, though, and we don't know for sure, we don't know what's happening between these points. Could our velocity be negative between 8 times t equals 8 and time t equals 12? Could be. And so if we have a negative velocity and a negative acceleration, that means that negative velocity is getting more and more negative, which means it's then accelerating in that negative direction. So we have to be careful what we say there. I'm glad you said that, though, because that's an important point, okay? So, we can't say that the particle is necessarily slowing down or speeding up, because... Yeah. If we had more information, then we could then say, you know, and again, if I had to guess here, we could probably say it's decelerating, but we don't know. Okay? All right, let's go to another one here. Number 8. Now we have a graph. Pictures. So we should be able to do tables, and we should be able to do graphs as well. Okay, so let's look at the graph. The graph below represents the velocity, v of t, in feet per second of a particle moving along the x-axis over the time interval 0 less than or equal to t less than or equal to 9 seconds. Okay, so let me be very careful here. This is not the motion of the particle. Okay, this is not the motion of the particle. You don't, the particle is going up and then down and then straight. That is not the motion of the particle. This is just describing the velocity. Okay, this is the speed of the particle. Okay, so this is not like the path the particle is traveling on its merry little journey here. Okay, this is the velocity of the particle at certain t values. Okay, called the velocity. So these are just different speeds and things. Okay, so graph below shows that. Okay, so we're moving. So this particle is moving along the x-axis. That means the particle does not go up or down at all. The particle is only moving left or right. That's it. So it's staying on the x-axis. Okay. Let's do this here. So let's see. There you are. At time t equals 4, okay, is the particle moving to the right or to the left? What do y'all say? Take a look at that. At time t equals 4, look at your graph and determine, is the particle moving to the right or is the particle moving to the left? Okay. Alright, I'm going to call on someone. So let's see. Oh, Tyler. He's absent. He's got bronchitis. Alright, Joey. He sent me an email and said, Mr. Wood, I can't come in, I got bronchitis. And I sent him back. Ain't nobody got time for that. I showed him a picture, too. So. I was pretty proud of myself. Anyway, all right, so Joey, what was your answer here?
It goes to the right.
It goes to the right. So the particle, again, right, not it, but I understand you're just speaking to me, but hopefully you wrote the particle is moving to the right at t equals 4 seconds because
the velocity at t equals 4 is still positive.
Yep, and so really, if you want, you can literally just write this. V of 4 is greater than 0. And that's enough. Okay? Velocity of 4 is positive, right? That's what that greater than 0 means. It means positive. Okay. Okay. All right, let's go to, so any questions on that one? Pretty straightforward, yeah?
Yeah.
Okay. The reason why, guys, I'm really harping on us, I'm making sure we do good justifications like this, is because sometimes you get a point for the answer and then a point for the justification. And it's silly to get that answer point and then lose the justification point because you just didn't write down the reason why, okay? You probably knew the reason, you just didn't write it down. So when it says explain, you better explain because you're going to get a point for it, okay? All right, let's look at the letter B. Over what time interval is the particle moving to the left? Explain your answer. So what do we think here? Take a look at that. Try to think about what the velocity. How does the velocity describe the motion of the particle? And think about what time interval is the particle moving to the left. Okay, so Donovan, do you have an answer for that? When do you think the particle is moving to the left here? For what time interval? Yeah. Yeah, so I'm going to write an inequality here, compound inequality, and you're right, not equal to 5. Why don't we include the 5 here, Donovan? Yeah, exactly. The velocity is 0 then, so that's not moving left or right, it's at rest. So we're not going to include the 5, but we can include the 9. Why can we include the 9?
Because at 9 it still has a negative velocity.
At 9 the velocity is still negative, that's right. So there's our time interval. And let's see, I want to make sure I write this. For 5 less than t less than or equal to 9, the particle is moving to the left because v of t is less than 0 for these t values. You can do integral notation, that's fine. I think the AP test, yeah, they accept either way, as long as you get your point across. If you want to be really fancy, you can say, and use integral notation, you can use 4t, and you can put like this little like curvy e here. That's t element of 5 to 9, the interval notation there. That's like really mathy. Okay? Alright. At t equals 4, is the acceleration of the particle positive or negative? What do you say here, Austin? At time t equals 4, is the acceleration of the particle positive or negative?
I said the acceleration is negative at t equals 4.
Okay, so that is correct. The acceleration...
No, I'm going to speed.
Oh, screwed it up some there. Sorry, thank you. The acceleration of the particle is negative at t equals 4 seconds because why?
Because v of t decreases on the interval 3 to 6.
Yep, okay, so v of t at 4 right there, okay, it's decreasing. You could also say the slope at v of t is negative as well. Let me see here, did I write that? Yeah, I use that. Because the slope of the velocity, in fact, we can actually find the slope of that velocity, can't we?
Doesn't ask for it though.
It doesn't ask for it. Okay.
The direction.
Okay. So how could we find the slope at time t equals 4 here?
Slope formula.
Yeah, slope formula. What 2 points will we use to find that slope? 3 and 5. Okay, but what are the coordinates though? It'd be 3, 10, and then 5, 0. We could use those points, 3, 10, 5, 0, to get the slope of that segment of our line there. So we don't. So here's the crazy thing, guys. We don't know what this function is. We don't know what the function is, but we can still find the value of its derivative by just calculating the slopes. I can find the slope. I can find the value of the derivative all along here. It's this positive slope. I can find the value of the derivative all along here, and here's an easy one. What's the derivative all along here? Yeah, 0. Okay. Slope's value is 0. All right. Letter D. What is the average acceleration of the particle over the interval from 2 less than or equal to t less than or equal to 4? Show the computations that lead to your answer and indicate units of measure. Okay. So let's see here. So Drew, if I want to find the average acceleration, remember average acceleration is the same thing as saying average rate of change of what? Of velocity. So if I want to find an average rate of change, what do we use? The slope formula and those 2 points. Exactly right. So we want to find the average rate of change. So it's going to be v of 4 minus v of 2 over 4 minus 2. If I did v of 2 minus v of 4 over 2 minus 4, would that be okay? If I did v of 2 minus v of 4 over 2 minus 4, would that be okay? It actually would be okay. It would still be okay. It would still give you the same slope. Slope is just between 2 points. It doesn't matter which 2 points you use first, you'll still get the same answer. So v of 2 minus v of 4 over 2 minus 4, it's all right. Well, they would both be opposite. They would both be opposite, though, so the opposite part would cancel out. All right, so Drew, what is v of 4? Oof, let me see here. Hang on. You're right. It's kind of hard to read, isn't it? But let me see. I'd say 5. I'd say 5 there. I'd say 5. Yeah, sorry, the graph is a very thick line, and yeah. And what about v of 2? Can you read that one better? Yeah. Yeah. And then 4 minus 2 is 2. 5 minus 8 is negative 3 over 2.
Unit.
Yeah, so we need units of measure here. What would they be, Drew?
Feet per second squared.
Yes.
Yeah.
Yes, that's exactly right. Feet per second squared. Okay, again, because the velocity, we're told, up here in the directions, velocity is feet per second. So these numbers, 5 and 8, are in feet per second, and then we're dividing by seconds. So feet per second divided by seconds is feet per second squared. Okay? So that is the average acceleration. Okay, average acceleration. Boom. Questions on any of that? Okay, so why don't you guys go ahead and try this back one here then. Give it a go. See what you can come up with. It's not as fun. I know, I gave you guys the boring one. Womp womp.
Position on the x-axis is positive, then the velocity is positive. Therefore, like what?
So that's the graph. That's a graph of velocity. So the one on the back is a graph of velocity.
Yeah, okay, then.
Maybe
Wait.
So then, does this line denote velocity then, or is it
define the derivative of
See what now? Do what now?
Oh, never mind.
Yeah,
you're right.
Derivative
Yeah.
of that, and then plug in 0.
Smart thinking,
And
Ryan.
then it equals me, yeah.
So, yeah, for letter A, it has to be a velocity.
What do we use to determine whether the particle is right or left? Velocity.
So that's the right way to do it, just put in the derivative of the function, and that's the graph, then.
Now the graph of the derivative, yep.
This is velocity.
Yep. You can see how it gets a little tricky after think like, okay,
I'm not
position,
there
what
yet.
acceleration, what my graph I'm looking at, what do those parts mean? It's overwhelming.
Oh, that's the acceleration. So then you take the derivative again.
Basically, it's going right. If you're looking at it, it's slowing down.
I'll give you a few more minutes here, and then we'll get over this, because I also want to take a look at some other, make sure we get this done.
Inequality. Why don't you? Because if you look back on your very first page, acceleration is the derivative of the derivative of x of t. So, yeah.
How do you, so, you use
Or no.
All right, so we'll come back together here. I know you guys haven't maybe quite finished this up, but I do want to get through this so I can get you guys the assignment and stuff too. So, okay. So Connor, letter A. Were you able to come up with anything here?
I said it's positive.
Okay, it. Be careful. What is positive?
The particle's moving to the right.
Okay, the particle's moving to the right. Okay. How did you know?
Because I plugged a 0 into the equation.
Into what equation?
X equals t, but now I think you have to take the derivative of that. But
Yes, you want to plug the 0 not into the position, because the position does not describe movement, it describes the location, right? What do we use to describe the movement of the particle? What function describes the movement, how it's moving, left or right?
vt.
Yeah, velocity. So we,
Still moving in the direction.
okay, so that's good to know, but we want to be right for the right reason too, right? So x prime of t is equal to v of t, which is then 3t squared minus 12t plus 9. And so then v of 0 is going to be what? 9. Exactly right. So the particle is moving to the right because v of 0 is greater than 0. Or you can say, the velocity at 0 is positive, or you can say, the velocity at time t equals 0 is 9, so therefore it's greater than 0, which is positive. I mean, so, a lot of different ways you can say it. But v of 0 is greater than 0. That's what we really need to say. That's the most succinct way to say it, I would say. Okay, thank you, Connor. All right, how about Brandon then for letter B? At t equals 1, is the velocity of the particle increasing or decreasing?
It is doing neither.
Okay, so the velocity, you say, is neither increasing nor decreasing. How did you figure that out?
I figured it out graph calculator and saw that v of 1 equals 0. And we know that whenever the velocity is equal to 0, that is at rest. And at rest, it cannot be increasing or decreasing.
Okay, I see what you're saying. So when I throw like a ball up into the air, at some point the ball is going up, right? But then it's got to stop. And in an instant, the ball,
What's that point called? I think you know.
the vertex, or I would say the
First like an A.
apex.
No.
I think that would be work potentially too. But anyway, the point is, it's at rest. But before that point at rest, the velocity was decreasing, and then after that point at rest, the velocity will start to increase again in a negative direction. So just because the particle is at rest at a certain point doesn't mean the velocity is not necessarily, like, the velocity could have been increasing up through that and then decreasing down through it. What do we look at to determine the rate of change of the velocity? That is, when the velocity is increasing or decreasing. We have to look at the acceleration, A. So if we take the derivative, so A of t is going to be equal to 6t minus 12. And so at 1, it's going to be 6 times 1 minus 12, which is negative 6. Okay, so while, yes, the velocity at that instant is 0, the velocity overall is decreasing because we have a negative acceleration at that instant. Okay, so that's the idea. Okay, so the velocity is decreasing. Again, no it's, right? Always specify what you're talking about. So the velocity is decreasing at t equals 1 second because a of t is, or sorry, I should put a of 1. A of 1 is less than 0. The acceleration at 1 is less than 0. Therefore, the particle's velocity is decreasing.
Yeah, but you're talking about it's less than 1, it's also less than 3.
Okay. All right, letter C. Find all the values of t for which the particle is moving to the left. Okay, moving to the left means, what do we want to look at? A negative velocity. We want to see, when is v of t less than 0, right? What is v of t in our case? What's v of t, right?
3t squared minus 12t plus 9.
3t squared minus 12t plus 9. And we want to know when it is less than 0. Oh man, quadratics with an inequality. How do we even solve that? Factor it, yeah. So it does factor. So we can pull the 3 out. That's kind of nice. Okay, and then t squared minus 4t plus 3. That does factor. T minus 3, t minus 1. But then,
And set all those less than 0.
how do we solve this? Yeah, right?
So you just set them all less than 0. So 3 is less than 0, it's not, so you just cross that out.
So here's what I'm going to recommend here. This is a little bit tricky, and you have kind of like a right idea going there, but it doesn't work exactly like the normal ways that we do it. I suggest you make a number line.
Like when you divide, you have to change the sign and all that.
Right, exactly. And like, because here's the thing, if this is negative and this is negative, then that'll make it positive. But if one's negative and the other's positive, so it gets a little bit tricky. But here's what we can do. Make a number line using your zeros. Obviously, 1 goes to the left of the 3 because 1 is further left on the number line than 3, right? Okay, using your zeros, make a number line. 1 and 3, because 3 right there, 3 minus 3 is a 0, and 1 minus 1 is a 0. Okay, and then just pick a test point. So for example, what's a good number to use in this interval here? Yeah, 0. Okay, well, 0 doesn't plug in for 3, so 3 is just 3. 0 minus 3 is what? Negative 3. 0 minus 1 is negative 1. Positive times a negative times a negative. So it's like a positive times a negative times a negative. Okay, it's going to be positive overall. Okay, let's pick a number in this interval. What's a good number in this interval? 2. Okay, we'll plug in the 2. So let's check the 2. 2 minus 3, negative. 3 is always positive, so 2 minus 3 is negative. And then 2 minus 1, positive. So in this interval, it's negative. And then in this third interval here, pick a value. Let's pick 4, okay? Positive 3, 4 minus 3 is positive, 4 minus 1 is positive, so positive, 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 positive. Okay? So, for what values of t is the particle moving to the left? From 1 to 3. For 1, less than t, less than 3, okay, the particle is moving to the left. We don't have to justify here, but we can. Particle is moving to the left because what did we use to determine that the particle is moving to the left? Velocity is what? Negative, or I'm going to put less than 0. You could also just say because v is negative. Okay? Or v of t is less than 0 for those t values. Okay? Alright, last one here. Sorry guys, this is like a marathon here, I know, but I want to make sure we're good on these. Okay? Find the velocity of the particle and the acceleration is 0. Ooh, neat. Sounds like fun. Alright. So how should we go about doing this here? Let's go to Christian. What would you say? How can we go about doing this? What should we do first? Ultimately we want to find the velocity of the particle. But first we have to figure out what? When the acceleration is 0. So if I'm trying to find the velocity when the acceleration is 0, that means for this piece I'm solving for a what? If I'm going to know when the acceleration is 0, that means I need to get what value am I going to be solving for this when the acceleration is 0? We're going to solve for a t value. I need to find a t value here first. So how can I figure out when the acceleration is 0, Christian? How can I set that up?
Set the...
You're right.
For acceleration.
Yeah. 6t minus 12 equals 0. Exactly right. It's that easy. There's the acceleration equal to 0. And how can I figure out when that is true? What should I do here with this equation?
Solve for t.
You guessed it. Okay, so t is 2 seconds. So is that our final answer then, Christian? T is 2 seconds? We're done?
No.
Now what do we have to do?
Find the velocity.
Find the velocity at what time?
2.
So v of 2 equals, let's see here, 3 times 2 squared minus 12 times 2 plus 9. 2 squared is 4, times 3 is 12, 12 times 2 is 24. So 12 minus 24 is negative 12, plus 9 is negative 3. I was going to say, yeah, negative 3 what?
We're given a units per second.
Yeah, we're not really given a units of measure here, are we? So we can just leave it as negative 3 if you want. Yeah, I know, with like units per time. Yeah, it doesn't really work. So we'll just have to stop with a negative 3 there because we're not given any context.
So we can't really denote t then as 2 seconds.
Ooh, and I put not put 2 seconds there. You're right. I apologize. Thank you for saying that, Austin. I just assumed, but you do not assume. All right. So there it is. Negative 3 is our answer there. Physics is fun.
Fun with a P-H.
I like this.
I like this stuff too because there's like a meaning behind it now. It's not just like random stuff. It's like, oh, there's and it's like I think it's kind of a beautiful thing that position, velocity, acceleration is all related like that using calculus.
It is.
Yeah.
I think it's pretty cool.
It's pretty cool.
It makes me understand derivatives a little bit better.
Right.
When it does.
I hate doing